In this video, we will look at a few examples that will allow us to practice classifying special types of parallelograms. In example A, says what type of parallelogram are the ones below? And we have two different parallelograms. So in the first one, I noticed that all four sides are marked as being congruent. So that means that this parallelogram might actually be a rhombus or perhaps a square. The next thing I notice is that we have one angle which is marked as being 135 degrees. What this tells me is that this shape can't be a square because in a square, all four angles are 90 degrees. Therefore, this shape must be a rhombus, as well as a parallelogram. Remember, rhombus is just a more specific name for this shape. In B, I notice that all four angles are marked as being congruent. And what that means is all four angles must actually be 90 degrees because that's the only way for them to all be congruent is if they're all 90 degrees, since they have to add up to 360 degrees. So basically all four angles are right angles. So this might be a rectangle, or again, it might be a square. The next thing I notice is the 9 and the 5. Which means that all four sides are not congruent because 9 and 5 are not the same number. So it can't be a square because a square has four congruent sides. Therefore, this must be a rectangle. All right, let's go to example B. Is a rhombus sometimes, always, or never a square? Explain your reasoning. All right, so let's think about a rhombus. A rhombus is a shape with four congruent sides. So the question is saying, is a shape, a rhombus, with four congruent sides, sometimes, always, or never going to be a square? And a square has four congruent sides and four right angles. So any shape with four congruent sides will be a rhombus. So what that means is that all squares are rhombuses. But that's not what the question is asking. The question is saying, is a rhombus, so some random shape that has four congruent sides, is that going to be sometimes, always, or never a square? So the answer is sometimes. And the reason is there are definitely many rhombuses out there that are not squares. So it can't be always, because this would be an example of a rhombus that is not a square. However, there are some rhombuses out there that are squares, because there are many rhombuses that also happen to have four right angles, and therefore they are squares. So there are examples of rhombuses that are squares. So the answer is not never. Therefore, it has to be sometimes. Some rhombuses are not squares, like this one, and some rhombuses are squares, like this one. Let's last look at example C. List everything you know about the square, SQRE. So remember that a square is really a combination of rhombuses and rectangles because a square has four right angles, which is what a rectangle is, and four congruent sides, which is what what a rhombus is. It also has all the properties of a parallelogram. So it has a lot of properties. One thing we can say is that opposite sides are congruent. And in fact, all the sides are congruent. So that would be a better way to say that. All four sides are congruent. We also know that there are four right angles. We know a bunch of stuff about the diagonals. The diagonals have to be congruent, which means that EQ is the same length as SR. And it should look like that if you look at it. The diagonals are congruent, but they're also perpendicular. So they meet at a right angle. And they also bisect each other. So there's a lot of stuff about diagonals. And there's actually one more thing about diagonals. They don't just bisect each other, but they bisect their angles as well. So each of these angles has been cut in half. So each of those angles would end up being 45 degrees going all the way around like this. So they bisect their angles. And one last thing that we know is that the opposite sides are not only congruent, they're also parallel.